Hello students, welcome to my channel Arun's Physics Portal. In this lecture, I will discuss about the shift registers. This topic is meant for MSc students of Physics and Electronics and also for BE and BTech students of EEE and EC branches. The research scholars will also find this topic useful. The complete note of the topic is given here for your convenience. I hope you enjoy going through it. Now let us come to the topic. Shift register. We have already seen what is a register. A register is used to store a binary word, which may be 0 or 1. A shift register shifts these stored bits either to the left or to the right. There are two different methods for shifting the stored bits into a register. In the first method, the information is shifted into the register by shifting one bit per clock pulse in series fashion, and this leads to the development of a serial shift register. While in the other method, all the bits are shifted into the register at the same time, and this leads to the development of a parallel shift register. Shift registers are commonly used for temporary or intermediate data storage. They are extensively used in arithmetic operations like multiplication, division, and taking the complement of a binary number. Shift registers are also used to realize ring counters and may be used as a digital delay line to reduce a time delay, which is an integral multiple of the clock period. We now discuss the two types of shift registers. We now come to serial shift register. There are two types of serial shift registers. One is shift left register and the second is shift right register. In the shift left register, the stored bits are shifted one place to the left with each clock pulse. And in the shift right register, the stored bits are shifted one place to the right with each clock pulse. Figure 1 shows a 4-bit shift left register. So this is the circuit diagram for a 4-bit shift left register. These are the inputs and Q's are the outputs of each flip-flop. The output of this flip-flop Q0 is connected to the input of this flip-flop on its left. Similarly, output of this flip-flop Q1 is connected to the input of this flip-flop to its left, and the output of this flip-flop Q2 is connected to the input of this flip-flop to its left. So that we have D1 equal to Q0, D2 is Q1, and D3 is Q2. It is shown in the figure that all the flip-flops are driven by the same clock pulse. And this symbol shows that the flip-flops are positive ace triggered. Now let us see how it works. So this is your figure 1, 4-bit shift left register. Let initially Q is equal to Q3, Q2, Q1, Q0, and this is 0, 0, 0, 0. Okay. We now make Di equal to 1. So D0 is equal to 1. So that the inputs to the flip-flops are, initial inputs क्या होगा, D3 is equal to Q2 equal to 0, D2 is Q1 equal to 0, D1 equal to Q0 equal to 0, and D0 equal to Di equal to 1. And the initial outputs are Q3 is 0, Q2 0, Q1 0, and Q0 is 0. Each clock pulse shifts the input to the flip-flops to their respective outputs, and each output bit shifts one place to the left. Okay? When each clock pulse hits the flip-flop, the input of each flip-flop is transferred to its output. And each output bit shifts one place to the left. That is, see here, Q3, Q2, Q1, Q0. We have shown arrow. So this moves to Q1 position. Q1 is shifted to Q2 and Q2 is shifted to Q3. We have put Di equal to D0 equal to 1. So initially Q3 is 0, Q2 is 0, Q1 is 0, and Q0 is 0. when the first clock pulse hits the flip-flops, then what is the value of di? Equal to 0 equal to 1. So this 1 is shifted to Q naught. Okay. The output of Q naught is shifted to Q1. So this was 0. So this is 0 here. This is shifted to this place. So this is 0. And this is shifted to this place. So this is again 0. So only the first output of first flip-flop to the right becomes 1 when the first clock pulse hits the D flip-flops. When the second clock pulse hits, then di is equal to 1. Okay. So this will be shifted to this place. This will be shifted to this place and this to this place. So when this is shifted to this place and this is shifted to this place, so this becomes 1. This shifted to this place, this becomes 1. This shifted to this place, this becomes 0. And this remains 0 here also. When the third clock pulse hits, and then also we have di equal to 1. So this is shifted here. Each bit is shifted one place to the left. So this is shifted here, this is shifted here, this is shifted here, and this is shifted here. So when this is shifted here, the third flip-flop's output Q2 becomes 1. And this shifted to this place, this remains 0. Okay? And when the fourth clock pulse hits the flip-flops, and when the di is still equal to 1, so this shifted here, this shifts here, this shifts here, and this shifts naturally here. So all the outputs are now 1. So long as di equal to d0 is equal to 1, further clock pulses have no effect on the output of the flip-flops, which remains at 1, 1, 1, 1. Okay? So this handwritten work was only to make you understand. Now once you understand it, you can write the note from the printed matter. Okay? We now make di equal to 0 and this is equal to d naught. So that the inputs to the flip-flops are, initial inputs are d3 is q2 equal to 1, d2 is q1 equal to 1, d1 equal to q naught equal to 1, and d naught equal to di equal to 0. And the initial outputs were q3 is 1, q2 is 1, q1 is 1, and q naught is also equal to 1. Okay? So each clock pulse shifts the input to the flip-flop to their respective outputs. And each output bit shifts one place to the left. So see how it functions. That is, we have Q naught shifts to Q1, Q1 shifts to Q2, and Q2 shifts to Q3. We now have made di equal to d naught equal to 0. So initially Q3 is 1, Q2 is 1, Q1 is 1, and Q naught is 1. We have made di equal to d naught equal to 0. So when the first clock pulse hits, this input di shifts to the output of the first flip-flop on the right. So this becomes 0. Output of this flip-flop shifts one place to the left. So this becomes 1. This output shifts one place to the left. So this becomes 1. And this output shifts to the left. So this becomes 1. So after the first clock pulse, output becomes Q3, Q2, Q1, Q naught is 1, 1, 1, 0. Okay? So when the second clock pulse hits, and then also di equal to t naught equal to 0. So this 0 shifts here, this input shifts here. So this was 0, this shifts to Q1 position. So the Q1 becomes 0. This shifts to this place. So this was 1, so this remains 1. And this shifts to Q3 place. So this was 1, so this is also 1. So after the second clock pulse, output becomes Q3, Q2, Q1, Q naught is 1, 1, 0, 0. After the third clock pulse, when di is still 0, so each bit shifts one place to the left. So this is 0 here, this 0 shifts here, this 0 shifts here. So this was initially 1, so this becomes 0 now. And this shifts to one place to the left, this remains 1. So output is now After the third clock pulse, output is 1, 0, 0, 0. Okay? And at the end of the fourth clock pulse, when di is still equal to 0, this 0 shifts here, this 0 shifts here, this 0 shifts here, and this 0 shifts here, so that the output of the flip-flop on the extreme left also becomes 0. So long as di equal to d naught equal to 0, further clock pulses have no effect on the outputs of the flip-flops, which remains at 0, 0, 0, 0. So this is the working of the shift left register. Okay? This was meant only for you to understand. So this will be written now. The entire matter that you want as note is given in the printed page. Okay? All that has been explained by hand is given here as note. Okay? That is only for explaining to you in a better way. For note purposes, the printed matter is sufficient. I hope you enjoy going through it. Figure 2 shows the timing diagram of shift left register. The change will take place only at the rising edge of the clock pulse. So this is the rising edge, this is the rising edge, and so on. Okay? Initially, we have made di equal to d naught equal to 1. So d naught will be transferred, or di will be transferred to q naught at the first rising edge of the clock pulse. So this is the first rising edge where q naught becomes high. Clear? So what is q naught? Is also equal to d1. So q naught is equal to d1. So d1 is also becoming high here at the first rising edge of the clock pulse. At the second rising edge, this is the second rising edge of the clock pulse. Here d1 will be transferred to q1. Q1 becomes high here. What is q1? Is also d2. So d2 is also high here at the second rising edge of the clock pulse. At the third rising edge of the clock pulse, d2 will be transferred to q2. So this is the third rising edge where q2 becomes high. What is q2? Is also d3. So d3 is also high at the third rising edge of the clock pulse. At the fourth rising edge of the clock pulse, d3 will transfer to q3. So this is the fourth rising edge. Okay, first, second, third, and fourth. So this becomes high here at the fourth rising edge of the clock pulse. Now, when we make d naught 0, we have made d naught low here or 0 here. So at the next rising edge of the clock pulse, d naught will transfer to q naught. So q naught becomes 0 here at the next rising edge of the clock pulse. So what is d naught? What is q naught? Is also equal to d1. So d1 is also 0 here. At the next rising edge, that means here, d1 will be transferred to q1. So q1 becomes 0 here. Okay. What is q1? Is also equal to d2. So d2 is also 0 here. At the next rising edge of the clock pulse, that means here, d2 will transfer to q2. So q2 becomes 0 here. And what is q2? Is also d3. So d3 is also 0 here. And the next rising edge of the clock pulse, d3 will be transferred to q3. So q3 becomes 0 here. So this is the timing diagram of shift left register. Okay. Next comes shift right register. In figure 3, we have shown a 4-bit shift right register built with positive edge triggered D flip-flops. All the flip-flops are driven by the same clock pulse. As shown in the figure, each flip-flop is set or reset by the flip-flop to its left, except the leftmost flip-flop, which is set or reset by the input bit DI. The operation of this register is exactly similar to the shift left register, except that with each positive clock edge, the stored bit moves one position to the right. This is the figure for 4-bit shift right register. Compare this figure with figure 1, the 4-bit shift left register. Here, the output of each D flip-flop is fed to the input of the flip-flop to its right. So this is the leftmost flip-flop, its output Q3 is fed to the input of the next flip-flop to its right. So Q3 goes to D2. Similarly, output of this flip-flop Q2 is fed to the input of the flip-flop to its right. So this goes to D1. And likewise, output of this flip-flop Q1 goes to the input of the rightmost flip-flop D0 here. The input bit is applied to the leftmost flip-flop DI. Okay, so DI equal to D3, Q3 is equal to D2, Q2 is equal to D1, and Q1 is equal to D0. All the flip-flops are driven by the same clock pulse, and this symbol shows that this is a positive edge triggered D flip-flop. Okay, so let's now explain how it works. Let initially Q equal to Q3, Q2, Q1, Q0 is 0, 0, 0, 0. All the flip-flops as shown are driven by the same clock pulse, and the flip-flops are positive edge triggered as indicated by this symbol here. We now make Di equal to D3 equal to 1. Okay, so that the inputs to the flip-flops are now, initial inputs are D3 is equal to Di equal to 1, D2 is equal to Q3 equal to 0, D1 is equal to Q2 equal to 0, and D0 equal to Q1 equal to 0. And the initial outputs are Q3 is 0, Q2 0, Q1 0, and Q0 is 0. Each clock pulse shifts the input to the flip-flop to their respective output, and each output bit shifts one place to the right. That is, Q3 is transferred to Q2, Q2 is transferred to Q1, and Q1 is transferred to Q0. So initially Q3 is 0, Q2 is 0, Q1 is 0, and Q0 is 0. At the first positive edge of the clock pulse, we put Di equal to D3 is equal to 1. So this is transferred to Q3. Okay. This output is transferred to Q2. This output is transferred to Q1. This transferred to Q0. So Q3 becomes 1 after the first positive edge of the clock pulse. Q2 remains 0, Q1 remains 0, and Q0 remains 0. At the second edge of the positive clock pulse, we have set Di equal to D3 equal to 1. So this one is transferred here, this one is transferred here, this one is transferred here, this 0 is transferred here, and this 0 is transferred here. So Q3 is 1, Q2 is also 1, Q1 is 0, and Q0 is 0. At the third clock pulse, we have still Di equal to D3 equal to 1. So this is transferred to Q3, Q3 is transferred to Q2, Q2 is transferred to Q1. So Q3 is 1, Q2 is 1, Q1 is 1. And this Q1 is transferred to Q0, which remains 0 here. And after the fourth clock pulse, we have still Di equal to D3 equal to 1. So this is transferred to Q3, Q3 is transferred to Q2, Q2 is transferred to Q1, and Q1 is transferred to Q0. So after the fourth clock pulse, output is 1, 1, 1, and 1. So long as Di equal to D3 equal to 1, further clock pulses have no effect on the output of the flip-flops, which remain at 1, 1, 1, 1. Okay. We now make Di equal to 0 equal to D3, so that the inputs to the flip-flops are, the initial inputs are D3 is equal to Di equal to 0, D2 equal to Q3 equal to 1, D1 is Q2 equal to 1, and D0 is Q1 equal to 1. And the initial outputs are Q3 is 1, Q2 is 1, Q1 is 1, and Q0 is 1. Each clock pulse shifts the input to the flip-flops to their respective outputs, and each output bit shifts one place to the right. That is, Q3 is shifted to Q2, Q2 is shifted to Q1, and Q1 output is shifted to Q naught. So initially we have Q3 is 1, Q2 is 1, Q1 is 1, and Q naught is 1. After the first rising edge of the clock pulse, we have di equal to 0. So the 0 will be shifted to Q3. Q3 will be shifted to Q2, Q2 will be shifted to Q1, and Q1 will be shifted to Q naught. So Q3 becomes 0, Q2 remains 1, Q1 remains 1, and Q naught remains 1. After the second rising edge of the clock pulse, we have still Ti equal to 0. So this is transferred to Q3. Q3 is transferred to Q2. So now Q3 is 0, Q2 is also 0. And Q2 is transferred to Q1. And Q1 is transferred to Q naught. So Q1 and Q naught remains 1 each. After the third edge of the clock pulse, we have still di equal to 0. So this is transferred to Q3, Q3 is transferred to Q2, and Q2 is transferred to Q1. So at this point, Q1 also becomes 0. So Q3 is 0 now, Q2 is 0 now, and Q1 is also 0 now. And this one is transferred to Q naught. So Q naught remains 1. And at the end of the fourth clock pulse, we have still di equal to 0. So this is transferred to Q3. So Q3 remains 0. Q3 is transferred to Q2. Q2 is transferred to Q1. And Q1 is transferred to Q naught, which also becomes 0 now. So this is Q3 is 0, Q2 is 0, Q1 is 0, and Q naught is also 0. So long as di equal to d3 equal to 0, further clock pulses have no effect on the outputs of the flip-flops, which remain at 0, 0, 0, 0. Figure 4 gives the timing diagram of a 4-bit shift right register. This is the clock pulse, and this is the positive rising edge of the clock pulse. This is the positive rising edge of the clock pulse. The changes takes place only when this edge hits the flip-flops. So when I keep di equal to d3 equal to 1 initially, then when the first positive edge of the clock pulse hits the flip-flop, d3 is transferred to q3. So q3 you see here from here that when the positive edge of the clock pulse hits the flip-flops, d3 is transferred to q3. So q3 becomes 1 here. Okay. What is q3? Is also d2 because q3 is connected to d2. So d2 also becomes high here or 1 here. Okay. At the next rising edge of the clock pulse, that is here, d2 is transferred to q2. So q2 becomes 1 here. And what is q2? Is also d1. So d1 also becomes 1 here. Okay. At the next rising edge of the clock pulse, this is the third rising edge. So d1 is transferred to q1. So q1 becomes 1 here. And what is q1? Is also d0. So d0 also becomes 1 here. At the next rising edge of the clock pulse, that means the fourth clock pulse, d0 is transferred to q0. So q0 becomes 1 here. Okay. So when I make di equal to 0, okay, then what happens? When di is made equal to 0, that means at this point, when the next rising edge of the clock pulse arrives here, q3 changes to 0. Okay, q3 changes to 0 here. So when q3 changes to 0, d2 also changes to 0 because q3 is connected to d2 here. At the next rising edge of the clock pulse, d2 is transferred to q2. So q2 also becomes 0 here. And so d1 becomes 0 at the same time. When the next rising edge of the clock pulse, d1 is transferred to q1. So d1 is 0 here. So q1 becomes 0 here. At the next rising edge of the clock pulse, which is here. And what is q1? Is also d0. So d0 is also becoming 0 here at the same time. and at the next rising edge of the clock pulse, D naught is transferred to Q naught. So this D naught is 0 here, so Q naught becomes 0 here at the next rising edge of the clock pulse. Okay, this is all about the timing diagram of 4-bit shift right register. So all the explanation that I have done here by hand is only to make you understand in a clear way how the circuit functions. So this is all about the shift registers, shift left register and shift right register. Let me remind you once again that the printed matter with the hand-drawn figures are sufficient for answering a question in the examination. हाथ से जो मैंने लिख के समझाया है वो आपको और क्लियर कंसेप्ट देने के लिए किया है, वरना printed matter is sufficient for you. Okay? I assume you like this presentation. यदि आपको मेरा यह प्रेजेंटेशन अच्छा लगा हो तो लाइक करें, शेयर करें और मेरे चैनल को सब्सक्राइब करें. So thank you for watching. See you next time with some other topic of interest. Till then, goodbye.